Hi everybody, welcome back for note 6.5. In today's lesson, we are going to be talking about adding and subtracting rational expressions.
Okay, so before we get started, let's review LCD. LCD, as we all know, stands for least common denominator. So, what would be the LCD of 1/2 and 1/8? Now, we learned in elementary school, you always start with the biggest denominator and you ask yourself, does the other denominator go into that one? So looking at 8, does 2 go into 8? In this case, the answer is yes. So 8 is going to be my common denominator because it is the smallest multiple of 2 and 8. Let's talk about the LCD of 1/5 and 1/7. Now, obviously 5 doesn't go into 7 and 7 doesn't go into 5. So we take our largest denominator, which is 7, and we go, okay, so the next multiple of 7 is 14. Does 5 go into 14? No. So the next multiple of 7 is 21. Does 5 go into 21? No, no, no. So then we go to the next multiple of 7, which is 28. Does 5 go into 28? Nope. So then we go to the next one, which is 35. Does 5 go into 35? And the answer is yes. So therefore, our LCD is going to be 35. Now there's a little trick. If you don't want to sit there and list all the multiples of 7 until you find one that 5 divides into evenly, you can just take those two denominators, multiply them together, and that's your common denominator. Now, sometimes in the end, if you follow that method, you might have to reduce in the end, but that's okay. That's just a quick little trick. Now let's look at how the LCD applies to rational expressions. So, same type question, now it's a rational expression. So what would be the LCD of 1 over x plus 2 and 1 over x minus 5? Now, obviously, it's kind of hard to tell, does x plus 2 go into x minus 5? So we're going to use the trick we learned on the last slide and say that our common denominator would be x plus 2 times x minus 5 because the product of the two denominators is your smallest multiple. Let's look at another example. What would be the LCD of 1 over x, 4 over x minus 3, 1 over x minus 3 squared, and 1 over 4? Now, this is a little bit more challenging. So I'm going to show you the answer, and then we're going to talk through why it is the answer. So our common denominator would be 4x times x minus 3 squared, because the product of the denominators is the smallest multiple. And you're like, but wait a minute, you've got an x minus 3, and then you've got an x minus 3 squared. So don't panic, we're going to talk about that. Let's talk about first, though. So when we're doing the denominators, we know it's going to have an x, and we know it's going to have a 4. So we know 4x is going to be a part of it. But where we run into a little trouble is right here with x minus 3 and x minus 3 squared. Now, think about it this way. If this was 3 and 3 squared, which is 9, 9 would be the LCD because 3 goes into 9. So in this case, we're just going to say that x minus 3 squared is the common denominator between those two because x minus 3 is already in x minus 3 squared. So that's why we only list x minus 3 squared, because x minus 3 is already a factor here. It's already taken into account. So let's jump in and let's start solving some problems. I apologize. I cut myself off. Not really solving. We are simplifying. I said solving. Really, it's simplifying. Okay, so we're going to simplify these. And I want us to add 1 over x plus 3 over y squared. So obviously, the denominators are not the same. So we have to determine what is the common denominator of x and y squared. Well, obviously we don't know. It's x. X doesn't go into y squared, and y squared doesn't go into x. So our common denominator is going to be the product of those two denominators. So our least common denominator is going to be xy squared. Now what we're going to do is we are going to multiply the top and bottom of each fraction by the piece of the denominator that we are missing. So that's what we're going to do. We're going to get common denominators. So when I look at x, 1 over x, well, my least common denominator is xy squared. What I'm missing from that is the y squared component. Well, I can't just multiply the bottom by y squared because that would change the value of the fraction. So the only way we can do that is if we multiply the bottom, we have to multiply the top as well. So we're going to multiply top and bottom by y squared over y squared. Now, y squared over y squared is just a fancy form of 1. So again, we're not changing the value of the fraction. We're just doing a little plastic surgery on it. We're changing what it looks like. So let's look at the next term. It's 3 over y squared. Well, from that denominator, we're missing the x. So we're going to do what we did for the last term. We're going to multiply top and bottom of that fraction by x over x. Again, that's 1. So we're not changing the value, we're just changing the way it looks. So now we clean it up. 1 times y squared is y squared. And 3 times x is 3x. So let me demonstrate what I just did there. 1 times y squared, and then 3 times x. And then we're going to combine like terms. Well, each term now is going to be over xy squared. So when we combine those, I have y squared plus 3x over xy squared. Now, we don't get away that easily. We still have to talk about domain restrictions and variable. Domain restrictions, variable restrictions, kind of the same thing. So let's talk about our variable restrictions. Well, right here, we know x can't be 0 because we can't have 1 over 0. And we know that y can't be 0 as well. Now, looking, that stays our denominator all the way through, so we're just going to simply say that x can't be 0 and y cannot be 0. So those are the only two variable restrictions that we have. All right, let's carry on. Ooh, let's look at this one. They want us to add 2 over x squared minus 9 plus 3 over x plus 3. Now, here's the catch. If we have a polynomial that can be factored, that's what we need to do. You cannot get the LCD of a denominator that is not in factored form. So what we have to do first is we have to factor x squared minus 9. So if you have a denominator that needs to be factored, you're going to want to factor that. So we already know by now, I'm back from Unit 4, that x squared minus 9 becomes x plus 3 and x minus 3. And then we have, of course, the other term of 3 over x plus 3. So when we're getting the common denominator, okay, we do not list this guy twice because we have x plus 3 and x plus 3. So if we didn't have that x minus 3, we would go, oh, okay, it's x plus 3. But because we have that x minus 3 component, then we can say that my common denominator is going to be x plus 3, x minus 3. Because when I look at him, I'm like x plus 3 and x plus 3. Oh, he's already taken into account right there. So we don't write him twice because he's already in there. Okay, so x plus 3 and then x minus 3. All right, let's get to finding some common denominators. I'm going to erase that little arc there. There we go. Okay, so on the first term, am I missing any part of my LCD? And the answer is no, because my LCD is x plus 3, x minus 3. So that's my LCD right there. I've already got it right here. So I'm not missing any part of that. But let's look at the second term. The second term is x plus 3. Well, my denominator is x plus 3, x minus 3. So I'm missing the x minus 3 component. So what I'm going to do, I can't just multiply the bottom. I've got to multiply the top and bottom by x minus 3. Because remember, x minus 3 over x minus 3 is 1. So again, multiplying by a fancy form of 1 and not changing the value, just changing how it looks. All right, so the next step is I have to kind of clean this up. So let's look here. Obviously that 2 doesn't need anything, but I'm going to take this 3 and multiply it right there. I'm going to distribute the 3 to x minus 3. Well, that gets me 3x minus 9, but I still have this guy to take into account as well. So 3x minus 9 plus 2. That becomes 3x minus 7 when I clean up that top. So I clean up the top, squish it together as one big fraction. Now, you're probably going, well, could I multiply the bottoms together? In theory, yes. Yes, you could. However, okay, here's the thing. I personally would leave them in factored form because that's going to make it easier when we do the lesson next week where we're actually solving and we're having to get common denominators and solving. You're just creating more work for yourself if you multiply those LCDs back together. So, dude, like seriously, I would just leave them in factored form. Just leave them in factored form. Don't multiply them back together. Okay? So, our final answer is 3x minus 7 all over x plus 3 times x minus 3. Because if you recall, we got the 3x here. And then we did 3 times negative 3, which was negative 9, plus 2 became 3x minus 7. Okay? So, and I apologize if I said 3x. Yeah, I said it right. 3x minus 9. Okay, so now let's talk about variable restrictions. So, our denominator, you can actually kind of look at your LCD because you're not flipping and multiplying on this. You're just doing LCDs. So really, your variable restriction can come from your least common denominator. So, looking right here, I know that x cannot be negative 3. And then looking at this term, I realize that x cannot be positive 3. So right there, that is our domain restriction. X cannot be negative 3 and x cannot be positive 3. And we're done.
Okay, let's look at our next example. Our next example is a subtraction problem. And they want us to subtract 4x over x plus 1 minus 6 over x. Now, you're probably wondering, why haven't we done a whole lot of subtraction examples? Here is why. Anytime you see subtraction, the first thing you want to do is to make it plus a negative. So anytime you see subtraction, you want to make it plus a negative. Trust me, you're going to thank me for this. It's going to save you so much trouble in the long run, because it's easier to distribute a -6 than it is to distribute a 6 and then have to remember that when you're subtracting everything that comes after it, you've actually physically got to subtract everything and change the sign. So this is going to make your life so much easier. Trust me on this. It will save you, hopefully, from making a mistake. The next thing we're going to look at is, okay, we need to get a least common denominator. So I look at my two denominators, x plus 1 and x. And I think, okay, so like, what is the LCD of x and x plus 1? Well, simply the easiest way to do it is to multiply x times x plus 1. We are now going to multiply the pieces of the expression by what we're missing from the denominator. So if you look at this first denominator, it's x plus 1. Well, I'm missing the x, so I need to multiply the bottom by x. But it's not just enough to multiply the bottom, you've got to multiply the top as well, because x over x is a fancy form of 1. So therefore we're not changing the value of that expression, we're just changing how it looks. Now, for the plus a -6 over x, you see that we're missing the x plus 1. So therefore, I'm going to multiply top and bottom by x plus 1. Now, I need to multiply the numerators and combine like terms. So 4x times x, that's 4x squared. Then we have -6 times x, which is -6x, and -6 times 1, which is -6. Now again, you could multiply the denominators together and make that x squared plus 1x. But trust me, you're going to want to leave them unmultiplied, because when we get to solving expressions in the next lesson, you're not going to want those denominators multiplied together. So just leave them unmultiplied. And this is a perfectly acceptable answer of 4x squared minus 6x minus 6 all over x times x plus 1. Again, don't multiply those factors in the denominator together. It's just going to end up causing you more trouble down the road. So just leave the denominators as factored. Now let's talk about variable restrictions. So if I look through my problem, I have x plus 1, x plus 1, and x plus 1. So right away we know that x cannot be -1, because if I do x plus 1 equals 0, I would get x is -1. I also know, because I have x here, and x here, that x can also not equal 0. Okay? So we end up with a final simplified expression of 4x squared minus 6x minus 6 all over x times x plus 1. And we have the two variable restrictions of x cannot equal -1 or 0.
Now, our problem is that they want us to simplify 1 over x plus x over y all over 1 over y plus 1. Now, you're going to notice that this looks very similar to the problem in multiplying and dividing that we looked at. And that's because, well, it is. So I'm going to show you and review you how to simplify it like we did in multiplying and dividing. And then I'm going to show you, after this way, I'm going to show you another way to simplify. So the first way is how we did it in the multiplying and dividing lesson last week. So what we want to do is, when looking at this problem, we've got to look at all denominators. So this guy has a denominator of 1. So what we want to do is we want to look at all of these denominators, and we want to find the least common denominator of all of those denominators. So we want to find the least common denominator of x, y, y, and 1. So, well, this y and this y, it's got to have a y in it. And then we have the x, and then we have the 1. So our least common denominator is going to be xy. So give me just a second. I'm going to erase all these markings so that it's clean and easier to look at. Okay, so now what we're going to do is we're going to multiply top and bottom by the LCD. Okay, we're going to multiply top and bottom by the LCD. Okay, now again, we're not changing the value, we are just changing the way it looks because xy over xy is 1. So this is going to help us clear those fractions on the top and bottom. So when we multiply by the LCD over the LCD, that's going to do something called clearing the fractions. Okay, so what we're going to do is we are going to take this xy, I'm going to multiply it by this guy, I'm going to multiply it by this guy, and then down here I'm going to multiply it by that guy, and I'm going to multiply it by that guy. So basically we're going to distribute xy to each part of the numerator and each part of the denominator. So let's look at what that looks like. Da-da-da-da-da-da! There it is. All right, so as you can tell, I've taken and distributed xy to each part. Now, watch what happens. Okay, so right here, this x cancels out with that x. This y on the bottom cancels out with that y. This y cancels out with this y. And then there's nothing to cancel out right here at all. Okay, so now I'm going to simply write what I have left. With the x's canceling out, I have y up top, and then with the y's canceling out right here, okay, I'm left with x times x, which is x squared, and then with the y's canceling out here, I'm left with x and then plus xy. So that's how I get y plus x times x is x squared, x plus xy. Now, let's talk about the variable restrictions because we have a few variable restrictions here. So I'm just going to erase my markings. Give me just a second. There we go. So let's talk about our variable restrictions, okay? So right here, we know that x can't be 0. So I'm going to go up here and do a little marking here. X can't be 0. All right. Then I'm going to look at this denominator. Well, y can't be 0 there either. Because remember, we don't want our denominators to go to 0. All right. Now, if we look right here at this denominator, okay, we also have y can't equal 0. So we're covered there. And then, of course, this one doesn't have a denominator. Well, it has a denominator of 1, but we don't have to worry about it. Okay? So we're good there. But here's a problem we have. So right here, even though this is a fraction in the denominator, we also have a denominator of the entire fraction. So we cannot let, okay, we cannot let 1 over y plus 1 equal 0. So 1 over y plus 1 equals 0. Okay, this is a 1. Sorry, I'm writing on the PowerPoint, and that is a y. Okay, so what we're going to do is we're going to solve this. So I'm going to have 1 over y equals -1. I'm going to erase that. That is a bad one. Woo! All right, so -1. And look what we can do. We can put that over 1, And oh my goodness, we now have a proportion. So I get negative y equals negative 1 when I cross multiply. Nope, not negative 1. My bad. Don't need that negative. Let's take him away. There we go. So we get, sorry, my bad. We get when we cross multiply, we get negative y equals 1. Now we're going to divide by negative 1. I was thinking too far ahead. So therefore, I get that also y cannot equal negative 1. Because let's look and see what happens if we let that y equal negative 1. Okay, so let's see what happens if we let this y equal negative 1. So we make him negative 1. 1 over negative 1 is negative 1. Negative 1 plus this 1 would make this whole thing go to 0. And that would give me a 0 in the overall denominator. So that's why y can't equal negative 1. So when we go to write our variable restrictions, we have that x can't equal 0 and y cannot equal negative 1 or 0. All right, so that's one approach. Let's look at the next approach.
Okay, let's look at another approach to simplify the same problem. On the last slide, if you'll remember, we multiplied the LCD of the entire problem by the top and the bottom. So we took the LCD of the entire fraction, multiplied it by the top. We took the LCD of the whole fraction and multiplied it by the denominator and cleaned it up. Well, this is just another approach. Instead of doing the LCD of the whole problem, we're going to do an LCD of the top, clean up the numerator. LCD of the bottom, clean up the denominator, and then we're going to do a flip and multiply so that we can clean up the fraction even more. So the steps here in the green box basically say what we're going to do. So we're going to clean up the numerator with an LCD, clean up the denominator with an LCD, and then flip and multiply. So looking at just the numerator, I can see that the LCD of the numerator is going to be xy. So looking at the first fraction in the numerator, it is missing the y. So I'm going to multiply top and bottom of 1 over x by y over y. For x over y, I'm missing the x in the denominator. So I'm going to multiply x over y by x over x. Now let's look at the denominator. I have 1 over y and then 1. Well, we know 1 is technically over 1. So the LCD of y and 1 is just y. So look at 1 over y. It's not missing anything, so I move to the 1 over 1. I am missing the y in the denominator, so I'm going to multiply 1 over 1 by y over y. I'm now going to clean up the numerator and the denominator. So I end up with y plus x squared over xy all over 1 plus y over y. Now I'm ready to flip the second and multiply. So if you recall, the second is going to be 1 plus y over y. So I flip that and I change it to multiplication. Now, I can tell that the y's are going to cancel. And there is nothing else that will cancel. So I'm just going to rewrite the simplified expression as y plus x squared over x plus xy. Oh my goodness, Holy Toledo Batman, this is the exact thing I got on the last slide. So as you can see, it doesn't matter which approach you use. If you like this method better, use this method. If you like the method on the slide before, use the method on the slide before. This just further proves that sometimes there's more than one way to simplify or solve a problem. Okay, so again, you get to choose the method that makes the most sense to you. Now, getting back to this problem, our variable restrictions are going to be the same because it's the same problem. We didn't change it. It's just how we simplified changed it. Again, you get to use whichever method you prefer, because again, if the math is correct, you're going to end up back at the same simplification.
So, formulas for the next slide. We got to get some formulas down because these might be some formulas you may have not seen before. So, we need to get some formulas down to help us solve the problem that's coming up. All right, so as you can probably guess, it's going to be an application problem. So, let's get this over with. All right, so formulas for the next slide. We all know this formula by heart, miles per gallon. So if you're trying to calculate the miles per gallon that your car gets, you take the number of miles you drove and divide it by the number of gallons that you used, hence miles per gallon. However, what if I wanted to solve this for gallon? What if I wanted to know what gallon equals in terms of mpgs in miles? Well, check this out. We can put miles per gallon over 1. And then if you remember your rules, so now we've got a proportion. And if you remember your rules for proportion, that means that we can take miles per gallon and switch it with gallon. If you remember back from proportions, it's called the interchange means property. I will say that again. Interchange means property. And basically what it says is you can switch the quantities that are on the diagonals of a proportion. So we're going to use that property to switch it so that we have gallons equals miles over mpg. Now, you may be wondering, why are those 3 dots in a triangle? Well, going back to math notation, that basically is shorthand for mathematicians to say therefore. Okay, so that way we don't have to write out therefore. We can say, hey, mpgs is miles over gallon. Therefore, if we solve for gallons, it's miles over mpgs. Okay, so that's a good one. We're going to need that, so hold on to him. Now, if I wanted the combined mpgs, now let's talk about combined mpgs. Couple different ways you can look at it. Combined mpgs, that is where, like, let's say you get so many miles driving in the city and so many miles driving on the highway, and you want to find out the combined mpg. You'll hear this a lot on car commercials, or when you're looking at those sticker thingies they put on cars. They give you the city mileage and the highway mileage, and then they say for a combined mpg of bleh. Okay, and that bleh is what we're going to find. Okay, so that's one thing. So if you want to look at cities and highways, cities plus highways, and get that, or let's say, you know, you have a car and your spouse has a car, and you want to find out the combined mpgs you get as a couple over a time period. So you can use this formula for that as well. So combined mpgs, we're going to take the miles of one plus the miles of the other, and then we're going to divide that by the gallon of one plus the gallon of the other. But wait a minute. Remember I told you that gallons are the same as miles over mpgs? So what do you think we're going to do? We are going to do a little substitution. So that we're going to put the formula for combined mpgs and gallons together, and that's going to give us our combined mpg. So as you can imagine, it's going to have the rational expressions on the bottom. Okay, it's going to have those rational expressions on the bottom. So that's how it fits into this lesson. But you're going to want to use this formula on your homework as well. So our application problem is going to be 2 cars, but I believe your homework problem is going to be city driving, highway driving. Okay, so you'll want to make sure that you keep this formula handy. All right, let's move on. Okay, so let's read the story problem here. A woman drives an SUV that gets her 10 miles per gallon. Her husband drives a hybrid that gets 60 miles per gallon. Every week they travel the same number of miles, which, let's think about it, if you're quarantining, you're probably not driving anywhere. But anyways, we'll assume this is pre-quarantine or post-quarantine, all right? So every week they travel the same number of miles. They want to improve their combined MPG, and they have two options. So the first option is tune the SUV and increase its mileage by 1 mile per hour, but keep your hybrid as is. So option one, they're going to give it a tune-up, and it's going to get 1 more mile per gallon than it did before. And they're going to keep the hybrid the same. They're just going to do that. And then option two is they could buy a new hybrid that gets 80 miles per gallon and keep the SUV as it is. Okay, so we're going to have to set up two problems and find the combined MPG for option one, and then we're going to have to find the combined option MPG of option two. So, and then we're going to compare who gets the better MPG, option one or option two. So, option one, let's talk about that. So, my SUV or her SUV originally gets 10 miles per gallon. Well, if we increase its mileage by 1 mile per gallon, it was at 10, it's now at 11, okay? So it was at 10, it now is at 11. And we're keeping the hybrid as it is, so the hybrid got 60 before, it's still getting 60 now, okay? So remember that formula from the last slide? We're going to pull him back up. But we're going to put it in terms of our problem now. So the combined MPG is going to be the mileage of the SUV plus the mileage of the hybrid divided by the SUV miles over SUV MPGs and the hybrid miles over the hybrid MPGs. So all I did was I took the formula from the last slide and put it in terms of SUVs and hybrids, okay? That way we know what we're plugging in. Now, let's think about this, okay? So I'm going to have to figure out the SUV miles and the hybrid miles. And I'm reading back through this problem, and I don't see that they give me that information. But they do give me something that is just as valuable. Every week they travel the same number of miles. So I don't know how many miles they travel a week, but I know that the two quantities are the same. So if I don't know something, I give it a variable. But since they're the same, we're going to let SUV miles be X and hybrid miles be X. Okay? So we're going to come right here on this top row here. Okay, that is a pretty pathetic looking arrow. I'm going to erase that. I don't like that. Okay, so as I was saying, we're going to go right here. And on this top row, we're going to replace SUV miles with an X. So we're going to replace this quantity with X and this quantity with X. Now, if you look at the denominator, it's miles over MPG. Well, we still, just because we moved to the denominator, does not mean that we know how many miles they drive yet. So we're going to let this guy right here, okay, we're going to let him still be X. Okay? Now, same with the hybrid. We're going to let him be X because these quantities right here, the hybrid miles, they're the same, and the SUV miles and the SUV miles. So those four quantities are both going to be represented by an X. Now, The other thing, we got to talk about MPGs. Well, we do know that. We know that the SUV gets 11 miles per gallon. And we know that the hybrid MPGs are 60. And that's where we got that information. So X is for miles, 11 and 60 for MPGs. So that our formula looks like that. Okay, now remember back to part 2 when we were cleaning up those rational expressions that had fractions in them on all stuff. Remember, it's basically the same example. So we need to get rid of these fractions. So we need to find, so we're going to use that first method that we did where you multiply top and bottom by the LCD. So we need to find of course, the LCD of 11 and 60, but also remember these guys are over 1. So now I don't want to sit there and just go 60, 120. No, I don't want to do that. Nobody's got time for that, okay? So what I'm going to do to get the LCD, and you'll probably want to use a calculator for this, I'm just going to multiply 11 by 60, okay? I'm going to multiply 11 by 60, and that is 660, because 11 times 60 times 1, that'll give you your common denominator. So 660. So I'm going to multiply top and bottom by 660. Now again, we're not changing the value of this expression. We're simply multiplying it by a fancy form of 1. We're going to do a little plastic surgery on it, all right? So moving to the next step. So I multiplied by 660, okay? Now, what I did here, I don't want to lose anybody, so I'm going to point this out. All I did right here was combine x plus x to get 2x. That's all I did, okay? So I didn't want to lose anybody there, but that's all I did. X plus x is 2x times 660. Now, what I did to get 60x and 11x is I took this 660 and I multiplied it right here by this guy. So 660 over 11 gives me 60x. Then I repeated the process and I took 660 times x over 60. So 660 divided by 60 gives me 11x. Okay? So now we can clean this up. So I'm going to do 660 times 2x up top, and on the bottom I'm going to do 60x plus 11x. And that gets me 1,320x over 71x. Now, what do you notice that's going to happen? What do you notice is going to happen? That's right. These two x's are out of here. So that gets me 1,320 over 71, and then you'll just type that into your calculator, or you can divide it by hand if you're, feeling like you want some fun division, and you figure out that you get 18.6 mpgs. Okay, so you get 18.6 mpgs. That's just option 1. Let's look at option 2.
Okay, let's look at option 2 now. So this time we're going to buy a new hybrid. So our new hybrid is 80 mpgs. And we're going to keep the SUV the same as it is. So we're going to see where that puts us as a combined MPG so that we can evaluate which option is better for us, option 1 or option 2. Now, the basic criteria, the basic information has not changed. They are still traveling the same number of miles in the SUV that they travel in the hybrid. So that's still going to be the same. It's the same amount. We don't know what that amount is, so we're going to let it be X. So anywhere we see miles in our combined MPG formula, we're going to substitute in X. However, the SUV MPGs will become 10 and the hybrid MPGs will become 80. So this is what our expression looks like. Now, you can do just like we did with option 1. Multiply 10 times 80, which is 800, and multiply top and bottom by 800 over 800. Or this time, I'm looking at my two denominators, and I'm like, well, I've got 10 and 80. I know 10 goes into 80, so I can use 80. So you can do 80 over 80. It does not matter. You're going to end up at the same result. Okay, so you can do 800 over 800 or 80 over 80. I'm going to choose 80 over 80 to keep my number smaller. So when I multiply by 80 over 80, I get 2x times 80 equals 8x plus x. Now let's examine how I got that. Okay, the first thing was I simplified x plus x to become 2x. So that's how I got 2x times 80. On the denominator, I took 80 times x over 10, and that got me 80x over 10, which is 8x. Then I multiplied 80 times x over 80, which got me 80x over 80, which is how I got x. So now I can simplify that further, and I can get 160x over 9x. So again, we notice that the x's go away, and I'm left with 160 over 9. Now again, you can do this division by hand, or you can use your calculator. I'm going to use my calculator, and I get approximately 17.8 MPGs. Okay, so we know that option 1, where we gave the SUV a tune-up and kept our hybrid, we got a combined MPG of 18.6. If we did option 2, where we kept the SUV as it is and bought a new hybrid, we only get 17.8. So we can tell that the husband is going to keep driving his car because it is better in terms of MPGs to tune the SUV. Because if we do option 1, we get 18.6 MPGs, and that's the best option. All right, well, that concludes today's lesson. I hope everybody has a great and wonderful day. Again, please, please, please remember, social distance, stay 6 feet apart, make good decisions, wear your masks, wash your hands, use hand sanitizer. And again, I hope everybody has a great day, and we will see you back soon. Thank you.